Hello, everybody. In Module 6, I discuss information processing costs and rational inattention. Module 6 has 6 lessons. Today, we focus on Lesson 3, Introduction to Rational Inattention. In a previous lesson, we discussed the early literature on information acquisition and processing. Those literature assume that investors incur some cost and then either understand the fundamental or some noisy version of it. How investors incur those costs and acquire and understand the fundamental or some noisy version of it is still a black box. Rational inattention provides a formal way to open the black box. And in doing that, connects information acquisition processing to investors' cognitive constraints and what kind of information investors are going to acquire and process explicitly. How is rational inattention literature motivated? It's motivated first in macroeconomics. The workhorse model used in macroeconomics is the so-called real business cycle models based on rational expectations framework. We discussed about this framework earlier in the modules as well. Rational expectations means that you're going to form expectations about exogenous underlying state and endogenous actions. But those expectations have to be rational, means that your expectations have to be consistent with the actual choice in equilibrium. And the underlying assumption of the rational expectation is that people form such expectations based on all of the information available to them. And they're going to take into account that others are going to do so as well. In addition, the decisions, the expectations will be formed instantaneously. Intuitively, such model is going to predict that decision variables such as prices and wages in macroeconomics models will fluctuate instantaneously and completely to new information. Such predictions, however, are inconsistent with empirical data. We have some examples in accounting as well. Post-earnings announcement drift, accrual anomaly. As we discussed in Lesson 1 of Module 1, when your theory is inconsistent with empirical findings, you need to have new theory. In this case, empirical findings come first, and then new theory comes later. The new theory, pioneered by Sims, is what we call the rational inattention models. Rational inattention relaxes the assumption that people can process all the information available to them and form expectations on them. Technically, what it does is it adds information flow constraints in the optimization problem. So in this case, even if the signal might be perfectly informative about the fundamental, people would perceive this signal to contain some noise, because paying full attention and extract all the information from the signal is prohibitively costly. The rational inattention framework generates sluggish response to new information, which better fits the observed empirical data. Because processing information is costly, whenever new information arrives, you cannot process that completely and instantaneously. So that generates underreaction to new information. What is the difference between rational inattention and costly information acquisition? They have some similarities and they have some differences. The similarity is that the literature on costly information acquisition assumes that investors incur costs to acquire information with higher costs for acquiring a more informative signal. The rational inattention literature makes this assumption too. The difference lies in two aspects. The first aspect is in a rational inattention literature, investors choose allocation of attention among various signals. For example, signals recognized in the financial statement versus signals disclosed in the footnotes. The second aspect is that investors have flexibility in choosing how to understand the signals. So investors, they're going to choose the underlying information structure. They're going to choose where they want to understand more, where they understand less, rather than just choosing the precision of a normally distributed noise, as in standard costly information acquisition models. And they're going to make this flexible choice subject to an information capacity constraints. Those two differences, they can potentially generate richer and more general implications. The second point, which we call flexibility, is so far most often ignored in the literature. So let's talk about a simple framework of rational inattention. Let's say an investor makes a trading decisions denoted as Y, based on their understanding of some earnings report X. and this earnings report has some prior distribution. The investor is going to choose how much attention to pay to X. That results in investors do not completely understand X, but they understand a noisy version of X, denoted as S. The more attention paid, the less noise in S. The investor then is going to make a decision based on S, or equivalently based on the posterior distributions of X based on S, which is LX conditional S. However, we assume no particular form on the posterior distribution. The posterior distribution can be any form. It depends on which parts the investor wants to pay more attention to it. And of course, paying attention is costly. Sims introduced a cost function based on entropy and mutual information, and this is deeply rooted in information theory. Sims used this concept to capture the cost of paying attention. So let's look at what entropy and mutual information mean. So entropy and mutual information captures information acquisition processing. It's related to information. The purpose of information is to reduce uncertainty. Therefore, a measure of informativeness is a measure of a reduction of uncertainty. If you want to measure reduction of uncertainty, you need a measure of uncertainty to start with. Now let's think about X. Without any information S, you have to rely on the prior. The prior uncertainty is measured by the entropy of the prior distribution, which the formula is given here. And so this entropy is going to be larger if G is less informative. So for example, if the prior is that X is certain to be some number of 8, then the entropy is going to be 0. So this delta X equals 8 in the slides means the direct delta function. I'm not going to explain that in more detail, but you can just Google it. When S is learned, the uncertainty of the posterior distribution is measured by the entropy of the posterior distribution, the formula given in the slides. Again, conditional S, the entropy is larger if S is less informative. And we can always show that the entropy of X conditional S is smaller than entropy of X, which means L is at least as informative as G, because at most, the signal S is useless. In that case, entropy would be the same. The difference between HX and HX conditional S is defined as the mutual information between X and S. The larger this difference is, the more informative S is about X, and the larger the mutual information. The rational inattention literature, they typically assume that the processing cost is proportional to the mutual information. And they would impose a constraint that the processing cost is smaller than some exogenously given upper bound K. And K can be interpreted as a cognitive processing capacity. The larger K is, the larger the processing capacity. A natural question is why we use entropy to measure uncertainty. Why we don't use variance to measure uncertainty. In a normal distribution, entropy is equivalent to variance. But that's the only case, that's the special case when entropy is equivalent to variance. In most of the cases, entropy is not equivalent to variance. Why is that? Why we use entropy? Consider the following example from one of my papers. Suppose we have n states, n is bigger than 2. And let's consider 2 scenarios. In scenario A, uncertainty is represented by, you have 1/2 probability of state being 1, 1/2 probability of state being n. The rest n minus 2 states, they're going to occur with 0 probability. In the second scenario, uncertainty is represented by, for each state, they have a 1/n probability of occurring. And we can check when n is bigger than 2, the variance of scenario A is bigger than the variance of scenario B. So based on variance measure, scenario A exhibits more uncertainty. But if you think about that from an intuitive sense, you would think that scenario A has less uncertainty because scenario A, you only have 2 possible outcomes. But in scenario B, there are n possible outcomes. Therefore, this Counterexample rules out variance as the measure for uncertainty. There is a paper by Shannon in 1948 which proves that entropy is the only construct satisfying a series of axioms that Shannon argues intuitively captures the measure of uncertainty. Before we go into detail of specific papers talking about rational inattention, here I offer some general insights. First thing, the flexibility we talk about is not an issue if the prior distribution is normal and the optimal decision you make is linear in X and unbounded. For example, quadratic or mean variance preferences. In this case, the optimal attention allocation always results in the posterior being a normal signal. And this is the case adopted in most literature that uses rational inattention. But you should be aware that this is only a special case. If you go to a more general case, then flexibility would become an issue. The general insights are, first, more attention is going to be paid when uncertainty is larger. Because in this case, when uncertainty is larger, more attention is going to pay off more. Reducing uncertainty is more important. More attention is paid when the fundamental is more important. So for example, if the decision Y depends on two signals, X1 and X2, then more attention is going to be paid to X1 if Y varies more with X1. Because in this case, X1 is more important in making decisions. If you have limited attention, you better save your attention for the more important signals. Attention paid to limited number of signals. So for example, if Y depends on M signals, and you have limited attention, so attention would only be paid to the N most important signals. To conclude, rational inattention means that people rationally pays less attention to information signals that are less important to them, given that they only have limited information processing capacity. Rational inattention explicitly introduces an information processing cost based on mutual information, which has deep roots in information theory. In the next lesson, we're going to see the application of rational inattention. We're going to see how rational inattention can explain the portfolio under diversification puzzle. If you want to test your understanding of this lesson, a review quiz of the lesson can be found at the link in the slides. Thank you very much.